All right, so get this. Elon has just revealed the identity of the second official Neuralink implant patient, and he successfully had the second generation Link chip implanted in July. In under a month, this patient has shown major breakthroughs controlling digital devices, and most importantly, his recovery's been smooth, no complications, unlike the first patient. So, who is this second patient, and what abilities has he recovered? Find out now. 1. Identity of the second patient. The second patient's been confirmed as Alex, an automotive technician with a passion for repairing and exploring all kinds of vehicles and complex machinery. Unfortunately, a severe accident left him with a significant spinal cord injury, robbing him of his ability to move and perform tasks like he used to. While Neuralink and Elon haven't disclosed the exact timing of Alex's implant, our sources suggest that he likely received the Neuralink chip about the third week of July, with the surgery performed at the Barrow Neurological Institute. Earlier on July 10th, Elon hinted that Neuralink would be conducting a brain implant surgery for the second patient in the coming week. The surgery was initially planned for June, but was postponed to July due to the patient's unstable health condition. By August 21st, we had finally received a lot of info from this patient, indicating that Neuralink's been carefully monitoring Alex's progress and response for over a month before officially announcing the results. It's worth noting that the first Neuralink patient, Nolan Arbaugh, also had his identity and remarkable capabilities after the implant kept under wraps for more than a month before being publicly disclosed. Clearly, both Nolan and Alex have spinal cord injuries, and Neuralink seems to be focused on these types of cases in the initial testing phase. However, as we mentioned earlier, despite having similar spinal cord injuries, there are differences in the invasive methods and chip design between the two patients. These differences aim to avoid issues that occurred with the first patient. 2. New chip and invasive method for the second patient. To help you understand why Neuralink had to change and improve the invasive methods and chip design for the second patient, we need to revisit the serious incident that alarmed the first patient. Specifically, after the first patient received the chip consisting of 64 soft threads thinner than a human hair that extended into the brain tissue, each thread had 16 electrodes, allowing a total of 1,024 electrodes to record brain signals after implantation. However, just about 2 weeks after the implant, 85% of the electrodes and threads had retracted from Nolan's brain, causing the chip system and signals to seem disconnected, with only about 15% of the threads still functioning. The CEO of the company admitted that air had become trapped inside Arbaugh's skull after the surgery, which may have contributed to the threads pulling out. Matthew McDougall, Neuralink's neurosurgery director, stated that the company had taken steps to eliminate the air pocket in the second patient. The company also implemented a plan to insert further threads deeper into the brain tissue and monitor their movement. Furthermore, as we know, more threads on the chip led to a firmer attachment to the brain, so the chip design itself was also revised for the second patient. Specifically, the Link chip for Alex will double the number of threads from 64 to 128. However, the number of electrodes per thread will be reduced from 16 to 8, resulting in the new chip for the second patient still having a total of 1,024 electrodes around the brain. With this change, Neuralink's neurosurgery director indicated that it could potentially double the bandwidth, allowing for more stable and accurate recording of neural signals. For the second patient, Alex, the depth of implanting the 128 threads into the brain tissue was also adjusted. Instead of the 3 to 5 millimeter depth used for the first patient, Neuralink's team decided on an 8 millimeter depth to achieve a lower retraction rate based on lessons learned from the previous incident. In addition, the Neuralink surgeons conducted to sculpt the surface of the skull to minimize the gap under the implant so that it sits flush with the normal contour of the skull. This, McDougall said, should minimize the gap under the implant and put it closer to the brain and eliminate some of the tension on the threads. As a result, Neuralink confirmed that no threads were retracted in the second participant, which is a very promising sign. These are the changes that have been made to the implant device and invasive methods for Alex. Before getting into the results and new capabilities of the second patient after getting Neuralink's chip, let's briefly review the implant procedure performed by the Neuralink team. Even with the adjustments in depth and chip design, the implantation process for Alex didn't differ that much from the first patient. Initially, surgeons made an incision about 5.8 millimeters thick on top of the head, opening it like lifting the hood of a car. Beneath the skin is the skull, where they create a 1-inch diameter circular hole. Remove this section of the skull, open the durometer, and then expose that part of the brain for the Neuralink R1 surgical robot. This is when the robot shines, as the surgeons cannot intervene. It can enter and place much smaller electrodes than a human hair with precise accuracy into the cortical surface at just the right depth and location to avoid all the blood vessels covering the brain's surface. After the robot completes its task, the surgeons return to place the implant into the skull's hole, secure it, and stitch the skin back together. The entire process takes several hours. After receiving the Neuralink chip, Alex also had to participate in research sessions of up to 8 hours a day, undergoing the progress of monitoring Neuralink's experts and doctors. 3. Neuralink's second human result. Like the first Neuralink patient, Nolan Arbaugh, the second patient, Alex, has also been able to perform a variety of tasks, control, and use digital devices just by thinking. Specifically, Neuralink confirmed Alex was discharged the very next day, and his recovery's been very smooth. By early August, Musk revealed that 400 out of the 1,024 electrodes in Alex's brain were already showing signals, even less than 3 weeks after the implantation. Let's say this, 90% of us are horrified by Neuralink and these chips because we fear we might die after the implantation. However, clearly from the first patient to the second, the results have shown very rapid recovery, early appearance of positive outcomes, and almost no lasting side effects. We're not saying Neuralink's 100% safe, but at least it's not as terrifying as we originally thought. Returning what Alex, the second patient's been able to do, with the Link chip, Alex has improved his ability to play video games and has started learning to use computer-aided design CAD software to design 3D objects. Neuralink stated that this is a significant step towards providing high-performance interface, which enhances digital device control for people with quadriplegia and helps them regain independence. From the moment Alex connected the Link to his computer, it took him less than 5 minutes to start controlling the cursor with his mind. Oh my goodness. Clearly, he's doing this better than Nolan Arbaugh. Could this be partly due to the tweaks we just talked about? Very likely. Within just a few hours, Alex was able to surpass the speed and accuracy he achieved with other assistance technology using Neuralink's WebGrid task, similar to what Nolan did on his very first day using the Link. Neuralink's second patient broke the previous world record for brain-computer interface cursor control using non-Neuralink equipment. After the initial research session, Alex continued to test the Link's capabilities independently, using it to play the first-person shooter game Counter-Strike. Before, Alex had to use a mouth-operated controller called Quad Stick to play the first-person shooter, but even then, the controller limited him to only moving or aiming his weapon at a single time, never simultaneously like a normal Counter-Strike player would. So in other words, Alex had to essentially switch back and forth between the mouse and keyboard functions while playing the game. But thanks to Neuralink, he can now aim with the implant and simultaneously move while using the quad stick. Just running around so enjoyable because I can look side to side and not need to move the quad stick left and right, Alex told Neuralink in a blog post. I can think about where to look and where it goes and where I want it to. It's insane. It shows him gunning down a bot enemy and then firing another from afar, all with total ease. After his injury, even though Alex wanted to learn how to use 3D objects using computer-aided design software to continue working independently, he struggled because current assistive technologies did not offer the level of control that he needed. On the second day using the Link, Alex tried Fusion 360 CAD software for the first time and designed a custom mount for his Neuralink charger. This was then 3D printed and integrated into his setup. As you can see, to the right of Alex's laptop is the 3D printed charger mount he designed using his Link. Neuralink's still working with Alex to boost his productivity with the Link by mapping intended movements to different types of clicks, left, right, and middle, thus expanding the range of control he has, allowing him to switch quickly between different modes in CAD software. Think zoom, scroll, rotate, click, and drag. In his spare time, Alex continues to use CAD software to bring his design ideas to life. The Neuralink team hopes that over time, the Link chip will help many people in their hobbies and pro fields. And they're excited to work with more individuals to help them reconnect with their passions. There's no denying that Neuralink has given Alex capabilities and opportunities he could never dream of before. Thanks to the Link, Alex has not only regained some of his motor skills and personal freedom, but has also pushed the boundaries of what he can achieve in various fields, from entertainment to work. This is just the beginning. After just 1 month using Neuralink, Alex is likely to set even more impressive records and achievements. And with Neuralink's many plans for development this year and beyond, there's no telling how far he's going to go. 4. Neuralink's upcoming plans. While updating on the promising results from the second patient, Neuralink also highlighted its future plans and improvements. Specifically, Neuralink mentioned that to further enhance the experience for trial participants using their digital devices, the company's continuing to expand the available controls. Neuralink's also working on decoding multiple clicks and simultaneous movement intentions to provide full mouse and video game controller functionality. Additionally, the company's developing algorithms to recognize handwriting intentions for faster text input. These capabilities aim not only to restore digital autonomy for those unable to use their limbs, but also to enable communication for those who can't speak, like individuals with neurological conditions like ALS. This year, Elon added that the company aims to implant chips in 10 patients with various conditions. Many are eagerly anticipating the Blindsight product, which aims to restore vision even for those with congenital blindness. And Elon announced it's going to be Neuralink's second product. As mentioned on his platform X, if all goes well, there will be hundreds of people with Neuralinks within a few years, maybe tens of thousands in 5 years, and millions in 10 years. Additionally, in their upcoming plans, the company intends to enable the Link chip to interact with the physical world, allowing users to eat and move more independently by controlling robotic arms or wheelchairs. In a conversation with Lex Fridman, Musk discussed the potential synergy between Neuralink and Tesla, particularly with the Optimus robot. Musk suggested that people who have difficulty speaking could communicate more easily through Optimus after getting a Neuralink implant. This means that your thoughts could be spoken by Optimus.
If someone has lost the use of speech, then they can still communicate to an Optimus.
Not stopping there, connecting the body to parts of Optimus and controlling them from Neuralink will also be quite feasible in the near future as both of Elon's technologies reach the pinnacle of their capabilities.
Let's say somebody has lost their arms or legs. We could actually attach an Optimus arm, Optimus legs.
It's easy to understand like this. In a normal, healthy person, the nerve commands from the brain will allow us to move our arms, legs, and other senses according to the actions we want. But in the case of the Optimus part, when a patient completes the implantation of both the chip and the Optimus part of the body, the neural commands from the brain, which are actually transmitted to biological limbs, can be transmitted to robotic limbs, allowing us to move and perform operations no less than a real arm or leg. Elon's also confident that the manipulation of your Optimus transferred arms and legs will be more flexible and responsible than your normal biological limbs. There's going to be less lag with the Optimus parts. If you think Neuralink is a technology that should be condemned and eliminated, try looking at it from a globalist point of view. Consider the cold, haunting statistics. There are about 180,000 Americans living with quadriplegia, and each year, another 18,000 face the tragedy of paralysis due to spinal cord injuries. We live in a digital age where our work, entertainment, and social lives revolve around smart devices and computers. But for those with paralysis, the ability to interact with the digital world is extremely limited, leading to a loss of independence, loneliness, and financial hardship. Neuralink, a project by Elon, has ignited new hope for those with spinal cord injuries and paralysis. The success of the brain implant for the second patient, Alex, has opened the door to a future that many once thought impossible. Just 5 minutes after connecting to the computer, Alex was able to control the cursor with his thoughts, a feat that previously existed only in sci-fi movies. This achievement not only demonstrates Neuralink's groundbreaking progress, but also affirms the potential of this technology to transform lives. Alex's story is a testament to the human ability to overcome fate and believe in the power of advanced technology. The Neuralink implant chip has given Nolan Arbaugh, Alex, and other patients a second life, overcoming the limitations of their bodies that they never thought possible. The success of the two patients was not a fluke, but the results of meticulous improvements after the failure of Neuralink's first surgery. Looking back at the difficulties faced by Neuralink's first patient, it's easy to see why many people are still concerned about the risks of this technology. However, Neuralink has learned from those mistakes and made significant changes to the chip design and implantation methods. By doubling the number of wires and adjusting the depth of the implants, the company has addressed issues that previously affected the system's effectiveness. As a result, Alex has done things that few could have ever imagined, from controlling a computer cursor to designing 3D objects while playing games just by thinking. Alex is living a life that he once thought was forever out of reach. And Alex's story does not end here. His success is just a small step in Neuralink's long journey. The company's got big plans for the future, from enhancing user experience to developing new applications for the chip. With Neuralink collaborating with other Elon technologies like Optimus, the potential for brain-computer interfaces is limitless. The prospect of a day when people with paralysis can move, communicate, and even work independently with the help of technology is no longer a distant dream. Experts believe that Neuralink's technology could have a significant impact, not just in medicine, like restoring mobility for paralyzed patients, but also in enhancing human abilities, something Elon often refers to as superpowers. Here's hoping that day comes soon. What do you think about Neuralink's latest patient update and Elon's next projects? Share your comments and opinions below. And we hope that you've learned more about Neuralink's second human trials after watching this episode. If you did, hit that like button and join your Tesla Car World family by subscribing to our channel. And don't miss out on any of our awesome videos by hitting the bell icon. We value your feedback and your time. Thank you so much for watching and see you soon. Until then, stay safe and have fun.